Data, no big deal, PySpark. All my materials are on GitHub. So you're a grown-up Python programmer, you've mastered using all these data technologies, you're proud of yourself, you should be. And then you hear people talking about big data, and you feel like you've just been demoted to the kids' table. So you say, okay, one more thing to learn, here I go. And you hear people talking about MapReduce. And you're like, you know what, they saved me a seat at the kids' table, is that really so bad? Don't panic. That's really the situation I was in when I started this year at Disney Streaming, which is really, really cool. At Disney Streaming, among all these big data technologies, we use Apache Spark, which is a nice one because it shields you from having to think about the details of MapReduce. And it has this wonderful PySpark library available. So how does this work? Well, we are going to use some distributed data, because really that's what people mean when they say big data. It means spreading that data out across potentially zillions of different disks in zillions of different places, so that zillions of different CPUs can access it all at the same time. Your big data technology is responsible for spreading the work out, gathering in the results, so that you don't have to be in the room where it happens. We are going to work with some disturbing but important data that the Washington Post has gathered on police shootings. So we need to start by spreading it out, by distributing it. We start with a few lines of boilerplate, and then we are grabbing our initial data source. In this case, it just comes as a single CSV, but for big data purposes, that's not very interesting. So we are using PySpark to write it out again, only this time we are making it partitioned by state, and then formatted in this binary format called Parquet. What does that give us? Well, it gives us a folder per partition, and within those partitions are files, at least one file per partition. And in this case, they are all local, but if I was doing this for real, I would actually probably do this on a real cloud service so that we could get that scaling power. Next, we create a PySpark data frame, which knows about this data in all of these different places. Note that Spark is not actually managing the storage of that data. It just knows where it is and can access it. A PySpark data frame works a lot like a Pandas data frame. When I run the show method, Spark sends my query out to all those different partitions, gathers the results, and displays them to me. The PySpark data frame supports a lot of methods. In this case, I am selecting and filtering so that I can narrow down both the number of columns and rows. And when I'm done with my transformations, which I can chain together in a fluid fashion, I run show to get the results back. I can use describe to get the rather disturbing statistics on any given column. I can group by, and that's a really important thing to do in big data. In this case, I just want to look at a count by city in Ohio. Maybe most importantly, Spark supports SQL so that I can do potentially really complex queries using my SQL powers. If you love Pandas, you're probably going to be disappointed by PySpark data frames because they don't support nearly as many methods. However, there's this cool library called Koalas, which basically adds in Pandas powers to a PySpark data frame while still letting it do its wonderful distributed business. So a Koalas powered PySpark data frame then can support Pandas methods like value counts, for example. And that's it. See, this isn't so hard. You got this. You can sit down at the big kids table. Not necessarily. Big data technologies are not better across the board. Often Postgres continues to rule as the best technology, but you can pick for the particular need you've got. I hope you enjoyed this, and I will see you all next year in person in Columbus. Looking forward to that. Thank you.